Alright, so this is question 6 of the final exam, and it says that a block with mass 2 kilograms is forced against a horizontal spring of negligible mass. Compressing the spring a distance of 0.20 meters, as shown in figure 7.47. When released, the block moves on a horizontal tabletop for 1 meter before coming to rest. The spring constant K is 200 Nm. What is the coefficient of kinetic friction between the block and the tabletop? So it's asking for the coefficient of kinetic friction, that is mu. It's asking for mu, right? Use this letter right here. It's like an M with the, like this. Oh, that doesn't look like it. One second. Like this. Anyways, so we have it's compressing 0.2, and then when it's released, it reaches 1.0 meters. All right, so the principle here is that the work net, meaning the sum of all the work, is equal to the change in kinetic energy, right? Change in K. So the thing is that K, in this case, the change of K is 0, right? Because K final is equal to 0 and K initial is also equal to 0. So to facilitate things, I already put that the work of the spring, right here, work of the spring, and the work of friction is going to act this way. They're equal. The work of the spring is equal to the opposite of the work of the friction, because obviously it was supposed to be like this, right? Supposed to be plus friction, right? But W spring. So when you pass to the other side, it becomes negative. So all right, became negative. So we get this equation right here. So again, in this equation, we isolate mu, and then we get half. And then we get this equation, right? We have K times X to the second power over MGS. So we have, if we plug in the numbers that says here, so we have here, we have spring constant. I'm just gonna put it like that. It's 200 Nm. Sorry. We have what else do we have? We have to what's it called? Shoot, we have all these numbers. I'm trying to read the title to get the numbers, but it's basically all here. So by just solving the equation, I'm sorry, I'm just really tired. By just solving the equation, we get half times 8, 20, and then this becomes 1, this becomes 4, and then this becomes 1, and then this becomes 5, and then we have 1 over 5, and that is equal to 0.2, which is one of the answers here. It's equal to B. So that is the whole explanation. The whole thing is understanding the principle here, and then given that the change in kinetic is equal to 0, we're able to put the opposite of the work of friction on the other side, and then plug in the variables of the equation, and then isolating the variable that we want to find, which is mu. And then when we plug in the numbers right here, we solve the equation, and we get 0.2 right here.